my mic working here? Here we go. All right, so Absen, a trusted LED provider, bringing the world into your studio. A quick little presentation about the challenges of LED in virtual production and how Absen addresses those technical challenges. So as we've been talking here today, virtual production combines many different types of technology to create a new dynamic, immersive environment for creating content. There's many different ways that you can do this, from matte paintings all the way to full LED volumes. When working with LED on film cameras, though, and new digital cameras, there are certain types of technical features that you have to support to make a really good-looking image. So, as we all know, the history of of virtual production over 80 years, there's been many different types of technology, but right now the key technology would most likely be LED technology used in these volumes. And Absen is very excited to support the virtual production market because it is believed that by 2026, the virtual production market would be about $5.4 billion US, that's globally, and that is a 25% increase year over year for the next 5 years. Now that is a global market number, and that also, of course, incorporates every aspect of virtual production, not just the LED or the technology side, but also includes the content and the other talent required for it. So why is virtual production so popular now in the way that we're doing it? Well, we bring the cost of post-production into pre-production, so that's not really an advantage, it's a change in the workflow. But now the different creative agencies are getting involved in the film in a different stage of the game. So that's one change in the way that the workflow is progressing. Virtual production is used in all sorts of different types of projects for cinema and episodic TV and commercial type applications. It's not just amazing science fiction that you can use for virtual production. You can create any type of environment in a virtual production set, which can really aid and assist in creating different types of content. Because PC processing technology has gained so much horsepower in the last 5 years or so, we're able to drive these very high resolutions with real-time rendered content. 10 years ago, it would be basically impossible to real-time render at even 30 frames per second a UHD pixel space. So the power of the PC, which has increased exponentially over the years, has enabled virtual production to really grow and blossom. There are many environmental factors which have a nice advantage for virtual production. So with typical filmmaking, if you're looking at going on location, there's a large cost associated with taking all of your talent and your crew and all of the gear that you need and going on location and then shutting down that location for X amount of time to create your shots. And then furthermore, you're then limited by weather and time of day and maybe even the talent that you're working with. For example, if your movie has children in it, well, there's very specific laws about how they can work throughout the day. So being on location might be even more limiting. Moving to a virtual production volume really gives a lot of flexibility and reduces the cost of that on-location shoot compared to shooting in a virtual production volume. So there are definitely a lot of environmental factors that virtual production has a nice advantage over with potential savings. Also the creative possibility. When you're trying to create a movie scene, let's say that you're trying to go across the Golden Gate Bridge at sunset, that might be a very challenging scene to actually do real world, but that's something that can probably be easily accomplished on a virtual production volume. So from a creative standpoint, it allows the directors and cinematographers to have different, more creative and flexible ideas that can actually be realized more easily on a virtual production volume. Timelines and workflows are definitely changed. I don't think it really decreases the amount of time of the overall shoot because you wind up moving the art department from the post-production to the pre-production, but you do get a final product after shooting much quicker because you tend to try to get final pixel in your shots instead of waiting for post-production to create the environments in your scenes. And of course, creating an actual environment on set makes acting with the environment much easier, and then of course you don't have to do that post-production with the green casting of a green screen type environment. So the types of virtual production that exist out there are a large range as well, from LED volumes, which would be the enormous volumes like Mandalorian has made, but that scales all the way down to smaller applications as well. The other major type of virtual production that is done is XR stages, or extended reality. And that uses very high-end media server systems like for Disguise, for example, that could take a set and extend it beyond the LED. So the physical LED stage is quite a bit smaller, but the virtual world that you create in that is actually sent to the broadcast feed is much larger. So that has some very unique applications for, let's say, corporate or live music events. And I think that XR is a great replacement for the smaller green screen applications. But XR probably is never going to be used for high-end cinema or episodic TV creation. So here are just some examples of an LED volume and an XR stage. Check the time here. We have a networking event coming up next. So what are the technical challenges of using LED in virtual production? Our last presentation from Brompton and Patrick went into a lot of those details and why Brompton processing is so important to have on a virtual production set. But of course, the LED also needs to support the features that Brompton can drive to make all these things come together. So with LED, we have to make sure that we can produce a very high percentage of the desired color gamuts. Now, in cinema production, DCI-P3 is typically the color space that you want to shoot in for a cinema-type production. So our products designed for virtual production are designed to hit approximately 98% or over of the DCI-P3 color space. And next generation technology that will be coming out is going to be designed to hit over 99.9% of DCI-P3 color space. And of course, by definition, if you can do P3 color space, then we're already hitting 100% of the Rec 709 color space, which is mostly used for probably 90% of the content delivery. HDR processing is necessary, not so much on the processing side, but ability to have the dynamic range and brightness to create an HDR type environment on stage so that later on you can create an HDR type piece of content. So having video walls that can be very bright but have that dynamic range is super important. A clear image on the camera, of course, is required, and there are many things that can cause issues with having a clear image on a rolling shutter camera, such as camera moire, but typically if you're focusing on the LED wall, that's not something that you try to do on a larger volume anyway, but could be a problem on an XR stage. But LED walls have potentially visible scan lines that can show up on a rolling shutter camera. And Absen works very hard to design technology to minimize these types of effects on rolling shutter cameras, and we work very hard to actually test our LED walls on these types of camera systems to know what we can expect for performance. So the features that we have on our LED walls, for example, are a maximum of 7,680 refresh rate for the pixels. Now, that is a very important number to support because that will work with the higher-end rolling shutter camera systems, such as an ARRI Alexa or Sony Venice or Red Camera or even Blackmagic rolling shutter cameras. So the very high refresh rate is a key feature to support for virtual production type products. Typically, LED designed for different applications for live viewing might only have 1920 or 3840 for a refresh rate, for example. Many of our products also support up to 250 hertz project frame rate, which is very important when you're doing frame remapping with Brompton, for example, or if you're trying to support high frame rate content. We always support 16-bit processing to make sure that our grayscales are super consistent, especially in the lower end. As Brompton was explaining, the last thing that you want is a color shift in your grayscale as you go to the lower end. We have different types of pixel technology that help reduce moire effects on camera, such as the integrated matrix diode or an IMD diode, which combines 4 pixels in one, essentially creating 3 separate types of grids on the LED wall, which makes it very hard for a camera to have a moire effect on screen. And we can actually show you that demonstration next door where you have both IMD technology and SMD technology. The advantage still of SMD is that you're going to have much lower black levels because of the shaders that are being used. So there's always an advantage and disadvantage to different types of technology, but Absen invests in research in both types of tech. Here's an example of our PL 1.9, and in fact, this is a color chart from the Brompton Hydra color calibration system. So we try very hard to hit these very high numbers for DCI-P3, and as I mentioned previously, next generation, our goal is to hit 99.9% of DCI-P3. This is an example of our color accuracy, And this is a very important number to understand how pure the colors can be, but what's also very important is understanding the color rendering index, for example. And LED typically does not create a full spectrum light that typically studio lighting creates. And understanding how we are using our LEDs and the primary colors that we're using to create a wider CRI is a very important feature for future development. This is an example of flip chip technology, which is used on our AX 1.2 product. The flip chip is very interesting because it reduces heat and power consumption, as well as creates very consistent off-axis color consistency, which is really needed when you're changing the angles of the camera to the LED wall. So that's a very key feature. So why is virtual production important to Absen, and why is Absen your solution? Well, we have technology that looks amazing on rolling shutter camera systems. We have a complete product line creating backdrops, ceilings, and floors. So we have an entire grouping of virtual production products that can create any type of VP solution. And we are constantly researching and supporting this developing market. So we believe that virtual production is going to be one of our key markets for the future, and we are investing a lot of time and energy to create the next generation of technology that will make filmmaking absolutely creative. So back to Tom. Thank you very much.
Perfect. Thank you. Thank you, Brian, everyone. Wonderful.
Thanks.
Thank you very much.
There we go.
Wonderful. So we're starting to get a feel for all the tech that we need in place now. We've looked at the systems, we looked at the tracking, we looked at the screens, we looked at what powers the screen. But then how do we start to apply that to our workflow, to our production workflow? How does that affect that? Well, we're going to round off the session with a quick panel. I think we're going to get some chairs out here, and bring those chairs out. We're going to build a panel here on the stage run by Absen's very own Tom Wachowski. Well, Tom, you there? Yeah. How are you? Come in with the chair. He does it all. He does chairs first, then he chairs. He's the chairman. Here you go. So we're going to do a quick chat about the production workflow, then we're going to take our first break. So it's just a thing to round off the session now to see how we bring all those systems into place to now apply to your production and to your team. So Tom, I'll leave you with it.